All right, class, I know I've been gone for several days, and let's just not worry about the work you did right now. Let's just pick up where we left off. This should be in your OneNote. If you wanted to split your screen and follow along with me and work through them, I ask that you bring headphones so that you could do that today. If you don't have your headphones, then if you want to have your class go through it, that's going to be up to you. But I think going through it individually will be your best bet. You can also go back and look at this at home later. Now, last week, I know it's been a long time ago, but we talked about the axis of symmetry. If you remember, the axis of symmetry basically takes the vertex. So in this particular picture here, if I just look by the picture, I'm not going to worry about the formula right now, we can tell that the vertex is the point -1, 2. Now, because this parabola is turned down, we know that that is a maximum point. So if I were throwing a ball, this would be the high point where the ball would reach, and then it would start coming down again. And we talked about a lot of that last week. Well, today we want to talk about, first of all, the domain and range. Now, this is not hard. Domain especially is not hard. So when we talk about the domain of something, we're basically talking about its x values. And when we talk about a function, which is all we're going to be talking right now about, the x values of this function will always be all real numbers. Now, we have a fancy way that we write that, and it's an R that kind of has two stems on it. So anytime you write the domain in your answer, that's my preferable way of you writing it. You can also put it in a solution set with these little squiggly marks, but that's not required. I think it's just a good idea. So the domain is pretty easy. Again, it's just all real numbers. Every single one of these we do, that will be the domain. Because basically what's happening is as this parabola opens up, it's going to eventually, if it went to infinity and beyond, it would eventually cover all x values in the right direction, and it would cover all x values in the left direction. Now, the range is a little more challenging, but it's really not that hard. Range are basically our y values. So that's not going to be everything. Because if you see in this particular parabola, the y values are going to be only the values that are going down through here, because we had a maximum point. So basically what we do is we take whatever our y value is in our vertex, and that's the number we're going to use. And then we use some fancy new language. Here's the way we write it. We write a y, and then we write a line, and that is read such that. So it's y such that y. Now, some of you have trouble with greater than and less than signs, so you're going to have to get that straight here. This is going down, so this is less than. So it's y such that y is less than or equal to whatever number we have here. So in that particular case, it's going to be 2. Now, you can always rewind this if you need to go back and look at that explanation again, and we're going to do several different explanations. So I have my domain, which is all real numbers, and I have my range, which is y such that y is less than or equal to 2. All right, now let's look at example 2. Now, if you notice in example 2, instead of having a maximum value, it has a minimum value. So this is like playing basketball. So you're bouncing the ball, and then we reach the minimum point, which is the floor, and then we come back up. And the minimum value in this particular example is the point -2, -3, which we also know is called the vertex. So again, if I need to give the domain on every particular function that we do, we're going to have all real numbers, and we're going to write it with this fancy R. When we write the range, we're going to write y such that y, and in this particular case, they're going up. The y values are going up, so this is going to be greater than. So y such that y is greater than or equal to whatever that y value is, which in this particular case is -3. Now again, if you need to look at that again, you can stop right here and rewind your video and look at it again. But I'm going to move on to example 7. Now, this is asking me to go back and find the axis of the symmetry. And we did this last week, so let's just do a quick little review of it. The formula for axis of symmetry is x equals negative b over 2a. And again, our a in this particular problem is 3. Our b is 12. And our c is negative 2. And as you can see in this particular formula, I don't need c. I'm going to go ahead and write it down, but in this formula I don't need it. So now I'm going to go plug in these values and see what my axis of symmetry is. So I'm going to get negative 3 over, let's fix that, put b wrong. b is 12, so it's negative 12 over 2 times a